All right, those of you that are here, we're going to go ahead and get started. So what we're doing is we're going into a new section this week talking about sound, okay, and how sound works. And as you read in your book, it gave us some definitions that we want to talk about. The first thing we want to talk about is compression and refraction. When something is compressed, that means two are coming together. Refraction means they're going apart. We're connecting that to our wave that we were talking about last week, and now we're going to be talking about sound waves. When things are being compressed, that is at the crest of the wave, and when they're refracted or refraction happens, that happens at the trough of the wave. So that was mainly the key point that we needed to talk about. Also, they talked about what a characteristic of a sound wave was. And it talked about an audio where you can actually hear. And as you can tell on your in your book today, it gave you certain ranges of what things are, from very, very soft sounds to very loud sounds, all the way up to ones that are thresholds of pain, which is painful to hear because it's so loud. It also gave us an exemplar of Doppler effect. What do you remember about Doppler effect?
I remember it was talking about the ambulance in the book.
Yes, sir. So, I think that is probably the best example that I know of. I know that if I'm driving down the highway, I can hear an ambulance, okay? Now, when the ambulance is behind me, it sounds very, very loud. And the closer it gets to me, the louder it gets. But then when it passes me and it's going away from me, it gets softer and softer and softer. And that's what it's talking about with the Doppler effect. It has to do the way that sound waves travel. So if I was something that was making a sound, and just think of it, the way I think about it is I think about on a lake, and I think about taking a pebble and dropping it or throwing it into the lake. And as that pebble goes, there are waves that come out, and they're just like sound waves. Sound waves travel just like that. As I'm talking, as I'm speaking, there are waves coming out just like those waves. Those have to do with compression and refraction. Those waves do go kind of up and down or out, okay? And if you are in front of me, you have a better chance of hearing me than if I'm speaking and you hear from this side. Think about it in the hallway. I'm very, very loud. If I'm facing you and I'm yelling down that hallway, I'm very, very loud, but behind me, I'm not as loud. And that's what they wanted to make sure that you understood, okay? So then the next thing that we want to do is we want to kind of get, and that's the main takeaway. And then we have this formula today. This is the only formula that we're using. And we're using I equals P divided by 4 pi r squared, which is intensity equals power 4 pi times the distance from the source squared, okay? So what we're going to do is we're going to go ahead and we're going to do our sample problems that we were assigned to. So question number 1, and I am on page 413. Question number 1 says, calculate the intensity of a sound wave for a guitar amplifier at a distance of 5.0 meters if its power outage is equal to the following values. So the first one was 0.25 watts, right? So let's see if we can see this really quick. So what we're going to do here is we're going to look and we're going to write down the variables that we have using the equation that we have up top. So number 1 tells us that the distance is 5.0, and that's our R. And it's giving us P1, and they're giving us 3 scenarios of that. The first one is 0.25 watts. So the only thing we have to do is we have to take this to find my intensity. So to be able to do that, you're going to do your power, which is 0.25 watts, and we're going to divide that by 4 pi times our radius, which is 5.0, and we're going to square it. So let's put that in our calculator. What I'm going to do is alpha y inner 0.25 over open bracket 4 pi, close bracket, open bracket 5.0, and then I'm going to do caret 2. And what did you get, Bailey, for number 1A?
7.96 times 10 to the negative 4.
Yep. 7.96 times 10 to the negative 4. Okay. For B, Jordan, the radius stays the same, right, sir?
Yes, ma'am.
And the only thing that changes was the power, correct?
Correct.
Okay, and what's our power for number 2 or B?
We had to use 0.50.
Okay, so what we're going to do this time is our radius is the same, right? But our power is different. So we put 0.50 watts over 4 pi. And this time we're going to use 5.0 still, 5.0 squared. All right, let me put this in my calculator. What did you get, Jordan, for that one?
1.6 times 10 to the negative third. I rounded up.
Yeah, that's fine. 1.6 times 10 to the negative third. Could you have done 1.59? Of course you could. Either one, I don't
Yes,
care.
ma'am.
Okay, so then let's look at C. So Abby, for C, what changes here?
P equals 2.0 watts.
Okay, so the radius is still the same. P3 is what I'm calling it. And you said it's 2.0 watts. All right. So for this one, I'm going to go ahead and say, all right, 2.0 watts over 4 pi. And my radius is still 5.0, right? And I'm going to square that. Put in my calculator. What did you get, man?
6.4 times 10 to the negative third.
Yep. 6.4 times 10 to the negative third, or you could have put 6.37. Also could be the right answer. So did anybody have questions about number 1? Everybody good with number 1?
Yes, ma'am.
That's pretty simple, right? So let's look at number 2. Before an eraser. For number 2, it says, at a maximum level of loudness, the power outage of 75 orchestra radiates to the sound at 70 watts. What is the intensity of these sound waves to a listener who is sitting 25 meters from the orchestra? So what are we going to do? We're going to do the same thing, aren't we? So for this one, Bailey, what is my power?
70.0.
Okay. And my radius?
25.0.
All right. And then I'm going to use my formula again, right?
Yes,
So
ma'am.
I'm going to take my 70.0 watts over 25.0 times 4 pi. And I'm going to square that. And what did you get, man?
I got 8.9 times 8.91 times 10 to the negative third.
Yeah, okay. Does everybody agree that's pretty simple? If you want to go over the other problems, I can, but if you feel like you're good, we're going to go on.
I feel good.
I feel good too, like James Brown said.
Well, you know. All right, so the last thing that I want to talk about is I want to talk about the ear, okay? So here is the ear model, okay? So on in your assignment, if you click on it, you will see a model that looks just like this one, except it's on yours. And I'm going to pull mine up if mine comes up. So what we're going to do is we're just going to track and kind of give the reasons why things you think are shaped the way they are. So this is just going to be an exercise, okay? So what I'm going to do is I'm going to break you into breakout rooms. You're going to have your own breakout room by yourself. And this is for you to give you a moment to think. And so what I would like you to do is I would like you to take the picture that you see, and I would like to see you trace how you think the sound comes from outside through your ear and through the nerve that goes to your brain. Okay, so you're just going to kind of do like a little flow chart. Does everybody understand what we're doing?
Yes, ma'am.
Okay, so like I said, I'm going to break you out in your own little group. So you're going to be all by yourself to give you a moment to think without me. All right, so I'm going to open your rooms for you. There comes some people. I got one. Here comes Bailey.
Just need one more.
I know. I know she's on because I asked her a question, she didn't answer me. So she might be having problems with her computer or something. Because she's yellow, so I don't know what that means. Okay, so some questions about this ear model, okay? This one here is a little different from your book, and I decided to use this one so that you could use both of them, okay? So first things first, why do you think the ear is shaped this way? Either one of you.
It kind of cradles the sound, so whenever something enters your ear, it's able to kind of like suppress that noise and allow it to go directly into the external auditory canal.
Kind of like a funnel.
Yeah, like a funnel.
Kind of like a funnel. Okay, so let's think of animals, okay? Now, is it important on where our ears are
Yes.
and
Yes.
why?
Because, like, if you're too high, the sound could like travel below, and if you're too low, the sound could travel above. And so, like when you think about a person, you're typically like face to face with them, and so I feel like the ear is in a perfect place to hear where their mouth is.
Yeah, and then sometimes if you have a problem, you put your hands behind your ear. That kind of helps you kind of funnel that noise, right? If you have to turn left or turn right, you can kind of hear. Think of animals beside humans. Ours is on the side of our head. Cats and dogs are up here, aren't they?
Yes, ma'am.
Mm-hmm.
Okay. And then is there another animal that has their ears differently than us, and dogs and cats? Where's a frog's ear?
That's a good question.
Isn't it just like a hole in the side of their?
It is. There's a tympanic membrane, just kind of like ours that we have here, and it is on the outside of their skin, and you can see because it's like little dark circles on the top above their eyes a little bit, like right here.
Oh yeah.
So just what they do is they don't have the outer ear canal. What they have is they have the tympanic membrane, and then they have the rest that goes inside.
Okay.
Why do you think that is?
I think sound is able to enter faster because it won't have to go through the canal, and it can get to their brains easier. And
I think it's
perceive
because
sound.
like frogs, like you know how we get water ear because water goes into our ear canals. I think with them just having like you said, that plastic eardrum that the water can't get in there and like mess up their ears.
I agree.
That makes sense.
How about a fish?
Same thing.
They don't have a tympanic membrane. What do they have?
Gills.
They do have gills to breathe with, but what do they have to hear with?
Can fish hear?
They're cochlea, right?
They don't have a cochlea.
Can fish hear?
Yes, they can. They have a lateral line. The lateral line runs down the side of their body. What they do is they actually detect waves and motion, and
They feel vibration, don't they?
Yeah, vibrations. Yeah.
There you go. So they don't need a tympanic membrane. They don't need a cochlea or anything like that. What they have is their lateral line that goes down the side of the fish, actually senses emotion, which they interpret as sound. Okay? So how does bats hear?
Isn't there like supersonic hearing?
So what they do is they actually produce a very, very high pitch that maybe we don't hear. And what that pitch sends out the sound wave, and then it bounces off of whatever object it's after, and it will actually come back to them as far as sonar goes, and that's how they find it.
So it's like sonar.
Yep, they don't see their prey, they don't use their eyes, they use sonar, which is part of their hearing. That's why their ears are like so big compared to their body, because they needed to have more energy and more cells built into their ears and their little mouth so they could actually detect theirs that way. Okay, so let's think about another elephant. How about an elephant?
They have really, really big ears.
They do.
Okay, so why do you think they have really, really big ears?
This might sound stupid, but because they're big animals.
That's what I was about to say.
I like that. They're the size of their body, right?
I was gonna say big brain.
Tiny, but their ears are huge. But compared to what the rest of their body is, you're right. They're very, what do you want to call it? Proportional, right?
Is
Okay,
it because like they're so big and like high up that they have to have like almost like a bigger net to catch the sound?
Right. So their ears are longer. And the reason that is for, like you said there, it's kind of like a bigger net. So they can hear, because they're way up, right? And way down. They're big all the way around. They would need to have that surface area so they could detect sound to come through. Very good. Abby, are you back? I think she is. Okay, so let's start first of all with Bailey. So Bailey, on your flow chart, you tell me where you start. I'm going to stop you, so go slow.
Okay.
And then Jordan can jump in and pick up where you were, okay?
Yes, ma'am.
So go for it.
I said that sound waves hit the outer ear and funnel into the ear canal.
Mm-hmm.
And then they hit the eardrum.
Yep.
And that vibration of the eardrum goes up into the semicircular canals and that middle area of the ear.
Right. So stop. So Bailey had a good question about the tympanic membrane or the eardrum. You will be able to see this when you come to school on Wednesday, but if you'll be able to feel it. But it's kind of like this membrane here, and it's kind of like a top to a soda that's brand new. Maybe not a soda, maybe a Pringles can. Let's do a Pringles can. You know how you have to peel that thing off, and you have that film that's on top that kind of protects on the inside? That's what that's there for. And what happens, like Bailey says, sound comes and hits that. And what I was telling Bailey, it's kind of like a pebble, okay? So the sound is pebble, and that pebble is coming through the eardrum, and your tympanic membrane is kind of like water. So when that pebble, which is the sound, hits this water, it creates waves, which actually gets with these things back here, which is called the inner ear, which is the hammer, animal, remember all that from elementary school? And those vibrations come through, okay? All right, Jordan, after I leave that, where do I go?
So after it hits those canals, it goes, that sound gets transmitted through these nerves in your ear. And after those nerves, they go towards the cochlea. And if you ever hear someone who has hearing problems or they can't interpret sound, there's something called a cochlear implant that they'll wear in their ear. And that actually sends the messages to the brain so they can perceive the sound. So that's what the cochlea does. It sends the messages right to the brain so they're able to hear and the brain can perceive that sound.
Okay, so which parts have fluid in it?
The eustachian tube, right?
The Coachella.
Yep. And the cochlea.
Yeah, the Coachella.
Go ahead, baby.
Is it, how do you say that? Is it Coachella?
Cochlea is what I call it.
Okay.
Cochlea.
Okay.
But if you have an inner ear infection, what's happened, is your cochlea here has an imbalance of water, like you said, for swimmer's ear. Also, for Jordan, what you said, people that can't hear, and I know we had a girl here last year, remember her? And she would have something that looked like something metal right here, and the wires would go inside. What it does is it replaces this because there is where your nerve is that's attached to it that sends the signal to the brain. Okay? But I mean, as you can tell, the ear is a very interesting thing and very temperamental. Like they used to say, wax buildup on your ear. What's the best way of getting wax out of your ear canal?
Whatever you do not use a Q-tip.
Okay. What is some of the solutions?
Like my aunt works at an ENT.
Yep.
And when I go, like when he removed my tonsils, he checked my ears and everything, and he used like almost like a little vacuum thing,
Mm-hmm.
and then he used like a really thin scraper.
Yeah.
And it felt weird, but once he got done, I felt like my hearing was magnified by like 100.
Give me his number.
Believe it or not, they have what's called ear candles. Have you ever tried those?
Oh, I've heard of those.
I've
They used to
seen
use
them.
those way back in like Revolutionary days and Civil War days. They used to use those a long time ago.
Exactly. But they are very popular to some people now, especially the people that want all natural. And basically, what it's just a candle. Put the candle in your ear, light it, and the light will cause the wax to pull out of your ear. I personally have never used it, but I've been very interested in seeing about it. But what you were talking about, Bailey, with the vacuum one, I thought that was very interesting too. And then, of course, you know, if you get water in your ear, what's the best thing for you to use?
Peroxide?
Peroxide. Oh.
Nope.
You turn your head over and you kind of like just let the water fall out. That's what I do. Or even
Yeah.
you vacuum it out.
Yep, that works. Swimmer's ear work, but there's something else that's over the counter that you could use instead.
The eardrops?
Yeah, what are they made out of? Do you remember? Eardrops?
I can go get
Saline?
them out of my bathroom drawer and tell you.
Is it a saline or saline solution? I don't remember.
No, it's not a saline solution. All right, that'll be the question.
Alcohol?
No alcohol.
That would be terrible. That would hurt.
There is oil that you can put in your ear that will dry your ear out. You'll put drops of ear in your ear at night, put a cotton ball on the outside of it. You wake up the next day, take the cotton ball off, and the ear is no longer have water. So I'm going to give you that as a question. So if you find out what it is, when you turn this assignment in today, make you do a private message and tell me what kind of oil you would use to put in your ear that will dry your ear out. Now, the other question I need to ask you, what does the stationary tube do?
That actually connects to your throat. So like your nose connects to your throat. So it actually tries to hold like the pressure in your ear and make sure it's at the right pressure.
God, whoever taught y'all about hearing is fantastic. So why do they say babies have more ear infections than adults?
It's kind of hard for them to clean their noses and their ear. No, well,
Because of that tube. Because when babies lay down to drink their milk and things like that, the milk gets built up in their throat, which will go back into those tubes. Have you ever heard of kids having an ear infection and they put tubes in their ears?
mm-hmm.
Yes, ma'am.
And what that is that's for this stationary tube not to fill back up with milk, and that's the reason why kids should not lay down while they're drinking. Interesting, huh?
Oh, I never knew that.
Yeah, well, I knew it because I tell my daughter all the time, about Paisley. I'm like, look, you better sit her up. If you sit her up, you'll be fine. If you don't sit her up, you're going to have a problem with the ear infection. And she, knock on wood, she hasn't had any. So it's been good. But we will, I am going to have some ears for you to actually physically touch and see when you come back on Wednesday. We're also going to be talking about the eye too. So that's going to be interesting. And we're going to be talking about being able to see that. We'll probably talk about that a little bit tomorrow. And then I'll have both models up here so that I'm trying to find enough models for everybody so everybody don't have to share. And we'll see how that goes, at least to have you touch them so you can actually see them. But besides that, that's the end of the day. I think it was a very easy lesson. I hope you read the question of the day, because the question of the day told you to go ahead and start a new ISM book. So remember when I gave you your ISM book, there are taped together. So what I'm going to do when you come on Wednesday, I'm going to cut the tape off of your ISM book. You're going to give me one of your ISM books that you've got done. The other one you're going to start on, and then we'll put them back together at the end, because that will be your first test grade, is me checking your ISM book. So make sure that you spend, which I think all of y'all have just been like super awesome. Just make sure everything's in order. Make sure you have everything where it's supposed to be. And then make sure you're ready to turn that in on Wednesday. Any questions?
I still need to finish some of my table of contents. I got a little bit behind. I think
Yes,
maybe
sir.
Wednesday, if that's okay.
Well, just as long as I can have it by Thursday.
Alrighty.
That sound
Thank
like
you.
a deal?
That's the deal.
All right, if y'all can pass it on to everybody else, I videotaped this, so I'm going to put this up for those people to see that wasn't able to come today. And I appreciate y'all coming, and y'all have a blessed day.
You too.
No senioritis.
No senioritis today. Today was
No.
not painful.
It was not.
See, and that's what's so great. It's great thing about it is we're out of the painful part, and we're going to be getting into the interesting parts now.
I tell you what, today was interesting. You taught me some things I did not know.
Well, you impressed me with things that you knew, so I was very impressed with you too. So thank y'all for coming, and y'all have a good day, and I'll see you tomorrow, okay?
Yes, ma'am. See you
God
tomorrow.
bless. See you.
Bye, honey. God bless you.
Bye.